Today we're starting section 11.3 and we're going to talk about limits and continuity. So here is 3 different pictures that we've seen over the past few days. So some vocabulary you're going to hear today is interruption versus a jump. So this first picture has a interruption because of this spot right here. There's open. F of A is not defined. However, the limit still exists. This middle one is called a jump. So if you envision your pencil, I'm going on one piece, then I have to clearly pick up my pencil and move it to a completely different piece of a graph. So this is what a jump looks like. F of A is defined. However, here the limit does not exist. So typically when you have a jump, the limit will not exist. However, F of A will be defined. And for the last one, F of A, this is again an interruption, F of A is defined, and the limit does exist. So there's all these different scenarios. So interruption versus jump, again, this is just kind of a visual to give you a picture. And today we're going to talk about asking if a function is continuous or if it has continuity. So there's 3 criteria it has to fit. F of A must be defined, the limit must exist, and the 2 things have to be equal in order for it to be continuous. So let me go back real quick. So notice this third one, F of A was defined, and notice the limit exists, but notice that these 2 y values would be different. So this would not be continuous. So continuity is the idea that you could draw your pencil on the whole thing and never pick up your pencil once. That would be continuous. So here I would have to trace my pencil along. I'd have to stop, go up to that dot, and come back down. So notice that is not one continuous motion. So for our first example, some things we need to find is f of 2 versus the limit as it goes to 2. So let's find f of 2 first. So when I plug in 2 in the numerator, I have 2 times 2 plus 1 over 2 times 2 squared minus 2 minus 1. So in the numerator, 4 plus 1 is 5. In the denominator, 2 squared is 4 times 2 is 8. And then I have minus 3. So I have 5 divided by 5, which would equal 1. So f of 2 equals 1. For the next one, for finding the limit, we would want to kind of factor that denominator. So I'm going to do that up here. So my combination multiplies to be negative 2, adds to be negative 1. There's a negative 2 and a 1. So I have 2x squared minus 2x plus x minus 1. So again, we group them. If you're a boxer, put all 4 terms in the box. For this first one, I can take out a 2x, and I'm left with x minus 1. I can take out a 1, left with x minus 1. So it's going to factor to be 2x plus 1 and x minus 1. So now I'm going to go back to the limit. So I have 2x plus 1 in the numerator, and I have 2x plus 1 times x minus 1 in the denominator. And notice these 2x plus 1's can cancel. So now I'm at 1 over x minus 1. When I plug in the 2 into that x, I'll get 1 minus 1, which is 1, so I get 1 over 1. So the limit, as I go towards 2, is still going to be 1. And because these 2 things are equal, I can say that this is continuous. Alright, so here is another one. So we're trying to determine if it's continuous at 2, so we find 2 things. F of 2 versus the limit as we approach 2. So f of 2 in the numerator I have 2 minus 2. In the denominator I have 2 squared minus 4. So I'll get 0 over 4 minus 4, which is 0. So this is undefined. So at this point I can stop because one of the rules said that f of a had to be defined. So this would not be continuous. So even though this one is not continuous, we can still find the limit as good practice. So the limit as x goes to 2, I have x minus 2 and x squared minus 4. Now, I know that this is difference of squares in the bottom, so I have x minus 2, and in the bottom I'll have x plus 2, x minus 2. So a set of these x minus 2's can cancel. So now I have the limit as x goes to 2 of 1 over x plus 2. So when I plug 2 in, I get 1 over 4. So the limit is a fourth. This is undefined. So again, this kind of proves that they are not going to be continuous. This would be an example of a jump. This would be an example of a jump, yeah. Alright, so that's all for today. We'll do some practice on this tomorrow.